Rudolph Auto EL4 ellipsometer. Soon after power up, the system will initialize. So initially the system will check for various parameters such as communication. If there is a SECS communication port utilized, it will check that port, and then it will home the stage. The stage is a very important part of the machine, and during the initialization or during any time of this operation, the stage should not be pushed or held. The stage can be operated from the joystick here. Moving it left or right will rotate the chuck, and in and out is move the stage in and out of the beam path. So I'm loading a sample, and then after loading it, press continue. The system operation is from the keyboard here and the joystick, and after loading the sample first time, it is important to make sure that the dot here, which is the auto collimator viewport, there's a CCD camera here, the dot should be centered at the center of this crosshair circle. There is a circle slightly visible here, and once you center it, press continue. So the system will start running the polarizer motor and the analyzer motor on the detector side, polarizer motor on the source side, and will prompt to operate the appropriate keys over time. The system source is a halogen lamp, 12-shalon lamp. And there are filters inside the polarizer side for various wavelengths. The wavelengths are in angstroms 6328, 6328 angstroms, and another wavelength 5461 angstroms and 4050 angstroms. So the lambda value can be entered or selected by running a particular program numbers, which I'm going to demonstrate. A detailed user manual will be included with the machine, and only trained personnel should operate this system. And before operating the machine, certain things are to be kept in mind. That is, the approximate thickness of the film should be entered, because the ellipsometry measurements are made in steps of certain thickness levels. For example, for a standard 6328 nanometer wavelength, there's a thickness called cycle thickness, which is 2825 angstroms. So up to 2825 angstroms, the system will display the thickness directly. Otherwise, there is a formula to calculate the thickness, but if we enter the rough thickness of the sample, then the system software will evaluate the order thickness and give you the exact thickness measurement, which I will demonstrate also here. So this is the crosshair, which is visible with the circle. Right now the sample is not in the beam path, so we don't see the dot in the center. So I'm ready to operate the system, so let's proceed. So there are, in the operation, there are several patterns we can enter. These pattern numbers are like a measurement at the center of the wafer, or 5 measurements at the center of the wafer, or measurements around the wafer, or it is also programmable. User can move the stage in and out or to the location, desired location, using the joystick and measure. Right now I'm entering 20, which is for a single measurement of the center of the wafer, and I'm going to select program 20, and this will enable the assumed thickness is 1000 angstroms, so that's the thickness of this standard as well. So I'm going to, if a known value is to be entered, we can enter it at this moment. For example, here I'm entering it 1000. To clear at any point of time, use the clear button. So we enter it. So there's a thermal printer on the system which prints as the system is in operation, and also it will print various program parameters such as pattern file number, program file number, measurement routine number, and calculation routine number. So currently the analyzer and the polarizer are set at an incident angle of 70 degrees, and there's a photomultiplier tube detector here. And the CCD camera here is connected to the monitor, the output of the camera. So here the system calculated both the upper layer thickness, which is 1083 angstroms, and the refractive index is about 1.460 units. Now I'm going to load a second wafer with a different thickness and do the measurement. So this standard is approximately 2236 nanometers. It's a Rudolph standard. So there are grooves on the chuck, and once you place the wafer in the center of the chuck and press run, and here again I use another program 21, and I use the program number 21. In this case, the system will prompt for the thickness, approximate thickness of the wafer. I'm entering it as 2200, and then the refractive index of the layer, so it is 1.462. I'm going to enter it. So after the parameters are printed, the stage moves in. So the measured thickness is 2222, which is pretty close to the value, desired value. It's a pretty used sample, and And the consistency, the measurement repeatability is pretty good. Okay. So the system also measured the standard deviation and average parameters for 5 measurements. So now I'm going to change the sample to a 9,000 angstrom sample. So this time I'm going to only measure once, and specified thickness 1000. I'm going to enter it as 9200. Enter. So this standard is supposed to be approximately 9,470. So it's measuring around 9,456. I'm going to measure a sample here, which is silicon nitride. And let's see, the program number for this sample is 26 I'm going to use. So to accommodate the variation in the thickness of the sample, there is a Allen screw down underneath here, under this disc. This screw should be loosened and this knob should be rotated. Rotating it counterclockwise will lower the stage and clockwise will raise it. And while doing so, the thickness of the film is 963 angstroms and it measured 961 angstroms. Sometimes to repeat the measurement we can press continue. So while adjusting the height, the care should be taken that the beam bounces off the sample, passes through the nose piece here, through the center of it. So at any point of time, to halt the measurement, the escape button can be pressed, and the reset button can also be used to reinitialize the stage. So that's the measurement here. So that's the sample silicon nitride. If necessary, the sample could be held using a vacuum pump. The vacuum connection is a 1/4 inch line on the back, and I'm going to operate the joystick to move the stage in, and then I'm going to demonstrate how the stage rotates. So the sequence of operation should be followed as per the instruction manual in order to operate it. The stage at the time of shipment will be locked on the sides, 2 sides underneath here, using the shipping brackets, and before turning on the system, the shipping bracket should be removed.